18. If the net force acting on a sliding block is somehow tripled, what happens to the acceleration? Use Newton's law of universal gravitation to rank the forces of attraction between each pair. An introduction to the practically important concept of ratio problems. Let's learn physics. I used to make it a habit of getting a different magazine every couple of years so I could learn as much as I could, the physics parts and the practical parts of as many topics as possible. Man, topics, right? Anyway, so I did this and I realized that as I was reading these magazine articles that, wait a minute, the physics that we teach you to do in general isn't the same character as the physics that normal people talk about. So why don't we add more of that and solve what I like to call ratio problems, or answer some basic ratio questions and really practical stuff related to equations. And anyway, let's take a look at this one. First one, I've been obsessed with bicycles for the longest time. This is Bicycle Times. I got Bicycling Magazine, etc. But they constantly talk about the rotating weight, the pedal mass, the shoe mass, the mass of your rim on your wheel, the mass of the tire, the mass of the tube, all that stuff. That's just rotational inertia, right? The moment of inertia, I is equal to sigma mr squared. There's a relationship there, very specific. And they all talk about the fact that if you reduce the rotating weight, the moment of inertia, then you can accelerate linearly better. And the angular acceleration versus linear acceleration, it's all in here. Sometimes numerical, but it's all in there. Here's one of my commuters. I could reduce the mass of the rim or the tire or the tube, and I could reduce the size of the wheel also. Those are moment of inertia questions. One is linear, one is quadratic. Another one, car crab. This thing is actually interesting. Now, I haven't built an engine, nor have I torn a big engine down, but building a new engine and the different spring rates that are necessary for lower mass valves and different piston masses and the accelerations for the piston and the linear to rotational motion transferences, and that's fascinating stuff. It's really good. And they constantly talk about the physics of it and the basic relationships. Here's another one, circle track. It's all about much more about suspension and setting up your whole vehicle to ride around on a circular track, and a lot of spring rates, a lot of angular accelerations, centripetal accelerations, inertia. It's good. Car turning a corner depends on mass, speed, and radius. There's a centripetal force provided by the friction force or the normal force, and there's a linear, an inverse, and a quadratic relationship all inside this equation for centripetal force. Motorcycle classics is another one. There's just really cool looking motorcycles here and some really high performing things. Turbochargers, superchargers, a lot of thermodynamics and some basic relationships there. Again, springs, linear acceleration, Newton's second law, mass versus acceleration versus net force versus torque versus horsepower. It's all in here. This one, American Rifleman and various firearm magazines, they talk all the time about the different bullet weights. The mass of a bullet with the same powder charge and what happens to the acceleration and the velocity as it comes out the muzzle, and the spring rates. As the slide comes back, the spring rate on that slide, the recoil spring, and the spring rate of the magazine spring, and all the other stuff that's involved there. It's pretty interesting stuff. Bunch of cartridges from 12 gauge down to a 22 LR. You could put the same exact bullet in a 38 Special or a 357 Magnum and fire from the same revolver. What would be the difference in accelerations and muzzle velocities? Rod and Custom. This, much more about tools and aesthetics and how to actually restore a vehicle, make it look cool and good stuff. And then final one for today, Wood Magazine, making things with tools and wood and lots of simple machines, lots of ratios, lots of torque, fascinating stuff. But this series is all about the things that are mentioned in regular People magazines and how to solve that kind of ratio problem, how to look at an equation and get a relationship from it and say, well, if I change this, what happens to this? And if I double this, what happens to this? If I add 10%, what happens to this? And exactly how that works. Super practical stuff. You'll see it all the time in the future if you're paying attention. Let's take a look. Stay tuned for the series on ratio problems. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.